I guess I should thank Philippe and Ufuk for inviting me, but you can see also there's a reason why they chose to do that. So the fourth author who's not present is Ari Hytinen. This crowd is well known, well versed in the innovation literature, so I can be brief on the motivation. There's a huge literature on that, but only a small part, though a growing part of it, is looking at innovation from the point of view of it being a human activity. And our paper falls into that group of the literature. And the key questions we're interested in this paper is, first, who becomes an inventor? And there we're especially interested in understanding how the background of an individual affects the probability of becoming an inventor, and whether we can say anything about whether there are barriers to becoming an inventor, and that then possibly has implications on the allocation of talent. As a society, we would want the best potential inventors to actually become inventors, otherwise there's a welfare loss. And secondly, we're interested, and hence the title of the paper, we're interested in how innovation is tied to social mobility. There's all this research and talk about changes in income inequality over the last decades and even centuries. Part of the puzzle potentially is innovation. And so in this paper we have a look at how the rents from innovation are divided, how much does the inventor get, if anything, and something that's not been done before in the literature. We also look at the co-workers of the inventor and see if they benefit from the invention. There's a huge literature on which we build. I'm going to be brief on this because I know I'm going to be running out of time. There's literature on allocation of talent. Baumol and Murphy et al. Almost a quarter century ago studied the question of, well, what affects the allocation of talent? They had more entrepreneurs in mind, but entrepreneurs and innovators, you can almost say, are the same thing in terms of modeling. The key question that they had in mind was, well, is talent going towards rent-seeking activities or towards activities that create new stuff, innovation being the new stuff? Later, there's been a literature that actually looks at the effects of this. Xie et al. Study the effects of increasing female labor force participation in the US. The other papers I'm listing here form the sort of core of the emerging literature on looking at inventors. So all of those papers, mine, Bell et al., Celik, maybe being the exception, and Gyuri et al., they look at individual inventors, what they look like and how one becomes one, and so on. There's also literature on division of rents. It's also not very big. There's a paper by John Van Reenen in the QJE 20 years ago that looked at the division of innovative rents without having access to individual level data. In the last 4 or 5 years, a few papers have tackled the issue looking at individuals. And Philippe and Ufuk have a paper that looks at state level data in the US and address income inequality directly. Now, you might wonder why we're interested in Finland, apart from 2 co-authors coming from that country. There are a few reasons why Finland would be of more general interest. Let me try to point them out. Here's a graph of Finnish GDP per capita over the last 100 years, the blue line, and you can see GDP per capita has grown 14-fold over the last 100 years. Finland is not unique in this, but it's one of the success stories of the last century. You can see that it's not because Finns are working harder, that's the green line. That's not true. They're working as hard or as little as they were 100 years ago. And so it really is about GDP per working hour, the red line. So innovation is the key also to Finnish prosperity. The other reason to look at Finland is that if you go back half a century, Finland was a backward country. Labor productivity per hour worked was less than half of that in the US, the frontier country. And you can see how Finland has successfully caught up in the intervening 50, 60 years, so that now labor productivity is between 80 and 90% of that in the US. Finally, in terms of comparing our results to those of Bell et al., who do some very similar things using US data, let me just point out that US here and Finland are quite different countries. So Finland has low income inequality. That's the x-axis, whereas US has relatively a lot of that. And then we have intergenerational earnings mobility here. And in the US, having a rich father really predicts you also being high income. In Finland, a lot less so. So we're looking at the polar extremes of the distribution here in terms of comparing our results to those in Bell et al. Now, given this background, given that Finland is, relatively speaking, a very equal country, there's comprehensive public health care, there's free education up to and including university level education with free government grants. One would expect that if anywhere, maybe in a place like Finland, allocation of talent would be quite efficient. Let's see whether that's the case. To give you a benchmark, we borrow from Bell et al. So this is the US. And what we have on the x-axis is father's income rank. So the lowest income fathers are on the left, and the highest income fathers are at the number 100 on the right. And we have the probability of becoming an inventor on the y-axis, and you can see how it's convexly increasing in father's income. How might this look like in Finland? Here's the answer. On the left, I have the previous picture from the US. On the right, I have exactly the same picture for Finland. And we see the same convex shape with the big increase after you go above the 80th percentile in Finland. Notice, though, that the level here at lower income levels is higher. It's above 0.05%, whereas in the US it's like 0.02%. So there's a difference at the lower tail, but these look strikingly similar, despite the countries being very different. And so part of our exercise is to start opening the box and understanding what's behind the right-hand side figure here. And just in case I really run out of time, let me walk you through our main results. First of all, we find that parental income matters even after we control for background variables, which I didn't do in the previous picture. This is likely not only because of credit constraints for reasons I'll get to in 10-15 minutes, hopefully. This impact of parental income greatly diminishes once you control for parental education and own IQ. And it's actually clearly smaller than the impact of parental education or own IQ. And these results are robust to controlling for parental wealth. Finally, IQ has a specific feature where the impact of that is convex to the very end of the distribution. And what's more, for the type of IQ, I'll get back to that in a few minutes, type of IQ we use, it has a bigger impact on becoming an inventor than on becoming a medical doctor or a lawyer, two professions that we use as comparison points. And finally, and not unimportantly, once you throw in a person's own education, that's an order of magnitude more important than any background variable. What about returns? Let me also give you a summary of our results there. We find a small but persistent increase in the wages of the inventor from the year of invention up to 10 years that we can follow. It's 0.5% to 2% per patent per year. These are tied to the quality of invention, so the better your invention, the bigger the returns. Others also benefit. So if I'm lucky enough to work next to an inventor, my wage goes up by 0.5% to 1% per year. How much depends on what type of a coworker I am. White collar and highly educated coworkers benefit more than blue collar workers. If I'm the entrepreneur in the firm, I benefit the most. I actually benefit more than the inventor, but mostly from year 6 onwards. So these benefits to the entrepreneur come with a lag. And finally, we find that inventing increases both social and income mobility. What do I mean by these? Social mobility is how closely my wage is tied to what my father was earning, and income mobility is how close my current wage is tied to what I was earning sometime, in our case, 10 years ago. Okay, the rest of the talk, I'm going to go through the data and some descriptive statistics. Yeah.
Maybe feel free to defer if you prefer to talk about this after, but since you were giving an overview of the main
Sure.
issues, I was just wondering if you could tell us what is your sense about your original question. You motivated the talk by asking about efficiency of allocation of talent. Can you answer that? And if so, what is your current take?
Yeah. So our current take on that is that that we cannot completely rule out that there are some allocative problems. So and by that I refer to parental income affecting the probability of becoming an inventor. Although we have reasons to think that those effects do not entirely reflect, say, credit constraints, but something else. And so I guess the way I would phrase it now is that compared to just looking at parental income versus looking at controlling a richer set of background variables, we're much less worried about allocative problems in terms of people becoming inventors than we would be if we only looked at parental income. But we cannot completely rule out those issues. Okay. So after showing you the data, I'm going to go through our results on who becomes an inventor. Then I'll turn to the returns part, and then, if time permits, I'll conclude. We use data from three sources. One is Finnish registry data. So every Finn or everybody living in Finland at the age of 15 enters a public registry that follows up on income, education, family, and so on. To these data, we've matched data from European patents, from the European Patent Office. So we know who's an inventor and what the invention looks like. And the third source is we have IQ data from the Finnish Defense Forces, and I'll go into the details next. So the registry data starts in '88, continues until today. We have available all the data until 2012, so it's an annual panel. We know many background characteristics of the individual: education, age, gender, where he or she works, and so on. And as I said, we have the entire Finnish working age population. To these, we've matched the population censuses from 75 and 85 to know more about the parents. So there we get information about parental education, where they lived, and what their income was. The IQ data, in Finland, young men still have to go and do military service, and some 85% of each cohort still do. In the first few weeks of that exercise, they're administered an IQ test, a very standard IQ test with 3 parts. There's a visual spatial part, a verbal part, and a quantitative analytic part. In this talk, let me emphasize, we're going to be using the visual spatial IQ test only. And the reason is that there's evidence showing that education affects, in particular, the verbal IQ part, but also to some extent the quantitative part. But there is no evidence that education would affect the visual spatial IQ score. So we can take that as plausibly more exogenous than the 2 other dimensions. Okay. What's important to know about IQ tests is that the test scores have been trending over time until mid-90s, and so when I talk about IQ points or IQ scores, we've normalized them by cohort. Okay. Matching Finnish data is easy because everybody has a social security number. Linking patents was less easy, but there we have a big list of information starting from the individual's name, employer's name, and various addresses, and we have something like a 90% match rate, which is pretty high in this literature. What does this give us? Well, we have 2 main estimation samples. For the who becomes regressions, we're going to be interested in those individuals for whom we have IQ data, That means that we exclude all women, we have to exclude all men born before 1961, and that leaves us with like 700,000 individuals. For the range regressions, where we don't have to make use of the IQ data, we can take all men who work in the private sector because only in the private sector we can link who you work with. In the public sector, we just know you're there. And so excluding the public sector excludes half of the working male population, but we're still left with roughly 900,000 individuals and more than 7 million observations. We further do these income and social mobility regressions as cross-sections, and there we use data first on men for whom we observe IQ, for whom we observe the father's wage, and we observe their own wage at age 35, leaving us with 360,000 individuals. And for the income mobility regressions, we want to observe not only somebody's IQ, but also income at ages 45 and 35, leaving us with 120,000 individuals. So those are the samples we'll be working with. Very quickly, we start with 12,000 odd inventors. Almost 7,000 of them are in the IQ sample. Very few are women. So that's obviously a big part of the allocation question. Unfortunately, because we don't have IQ data, we don't work on that dimension. Most of them have just one patent. Very few have many patents. They're highly educated and mostly in science. This is something that you would find in any inventor data set if you had this information available to you. Let's have a look at background. So you saw the income, father's income probability of inventing graph before. Here we have father's education. We start from base education, secondary, college, master's degree, PhD, and the blue bar is non-science and the red bar is science. And we can see that having a more highly educated father increases the probability of inventing, especially if the father has a science degree. Same for mother here on the right. Okay. So this looks pretty similar in terms of impacts than the picture on father's income looked like. Here's IQ. And now we have deciles normalized by cohort, and you can see how there's a big convex increase in the probability of becoming an inventor as a function of your visual spatial IQ. Finally, your own education, the same boxes, so base, secondary, college, master's, PhD, and you can see how having a advanced science degree really is the engine of becoming an inventor. So, to be a little bit more systematic, what are we going to be doing? We're going to be estimating linear probability models where the left-hand side variable is 1 if you're an inventor, 0 otherwise. And we're going to put in different controls. We're going to start with a list of base controls. And then the interesting controls will be parental income, parental education, IQ, and own education. Let me just open up a little bit how we treat parental income. So first of all, we observe it in 75, 85, and then from 88 onwards. The challenge we have is that we have parents of very different ages in our data. Okay? So what we do is for the oldest parents, we take the average of 75, 85 incomes. For the youngest, we take incomes starting from 88 from the years when they were 28 to 30. And we average, we deflate, and then we run a regression where we explain this wage with year of birth and year of measurement dummies, and we take the residual, and then we take the percentiles of that residual. So we try to clean out the fact that we have, some fathers are born in the 20s, some are born in the late 60s. To set the scene, here's the prediction from a model where we have background variables, a fourth-order polynomial in age, parent, decade of birth dummies, region dummies, urban dummies, language dummies, and dummies for the 4 lowest quintiles of father's income, and then we've split the last highest quintile into 4, okay? And this pretty much tracks the raw data. We get the same convex shape as you saw in the initial picture. What happens when we add parental education? Well, that's given by the red line, and you can see how the convexity is greatly diminished. We start in the same place, and at the lower end, there's essentially no impact. But at the higher end, we see a progressively bigger difference between the two graphs. Let me then further throw in the person's own IQ. We get the blue line, and you can see that we go further down on the right. And so I'm going to show some of the coefficients behind these regressions, but basically this graph tells us that when you control more richly for background and own characteristics of IQ, the impact of father's income, and actually more so mother's income, is diminished. Yep.
Just one question. So I appreciate that you sort of show us this very descriptively, but if I say we try to go a bit further and relate this again back to the initial question.
Mm-hmm.
So it seems one perhaps extreme interpretation is to say, well, a lot of this was driven by IQ, so by ability, so therefore maybe it's not so much about misapplication.
Mm.
Of course, the concerns, I can see two concerns. One is that perhaps both IQ and so IQ also captures parents' income to some extent, so because of measurement error. We regress IQ.
Yeah, so let Xavier finish his questions and then.
Just to be
yeah.
right. So the 2 points were first. One was this, right? Measurement errors with things, and then the second is that perhaps IQ is a better measure of permanent income of the parents. So
IQ, a measure of permanent income of the parents.
That is a better proxy for that.
Right.
So it's another form of
sure.
And then the last point is that even if we can say, okay, maybe IQ is all ability, there's still a big difference. So it's a factor of 2.5 between the top of the income distribution and the bottom.
Sure. Absolutely. So I'll get to the last of these later. The first two, we've looked at how IQ is correlated with parental characteristics, and the R-squareds are like 0.6. So there's very little correlation there. We also know, so what we've done here is we've also added parental wealth to these regressions. I don't have a picture on that, but it's essentially exactly the same. So to the extent that we can use direct measures of wealth, it seems that our results are immune to that, and wealth is our proxy for permanent income. So
I think if you look at the R-square, it's not surprising in its slope, because it's very much predict wages, but if you look at the point estimate, if you go 1 standard deviation up in the IQ distribution, you must go on average there must be an effect on wages. How could it not be? I agree that the share of variance explains.
You mean the IQ, the wage of the father? I'm sure there's a correlation. The correlations are actually not that high. So we've looked at the raw correlations, and they're of the order of 0.3. So they're there, but they're not tremendously high. Yeah. Yeah. So finally, let me throw in own education, and that's the green line. And you can see that we go further down, and now we see essentially almost a flat line up until the last income quintile, and there we see a jump, but a much smaller jump than before. That we haven't tried. So now we always work with percentiles of income. So we haven't looked at the direct measure of parental income.
Because it is like a double Pareto or like a log model, but it becomes then Pareto.
Mm-hmm.
Then I would assume like if the tail is very thick compared to the other part of the
right.
Then you will get this convex.
Okay.
But just look at the income.
Okay, that's a point we look into. Okay, let me show you some coefficients. So we have too many of them, so I had to be selective. So I'm going to show the effect of having a father or a mother in the top percentile. Okay, so F wage is father's wage and M wage is mother's wage, and you can see that in the first regression, having a father in the top income percentile as compared to having the father in the lowest quintile, there's a 1.8 percentage point increase in the probability, which essentially is twice the mean in the data. And having a mother similarly in the top percentile of the female income distribution gives a 1.4 percentage point increase in the probability of being an inventor. Once we throw in education, these coefficients go down by more than 50%. Okay? I picked up having a PhD father and having a PhD mother. You can see that having a PhD father gives you a 2 percentage point gain as compared to less than 1% from having a father in the highest percentile. When I further control for IQ, this coefficient and this coefficient go further down. The education of parents' coefficients also go down. And you can see that IQ has a big impact. And now I've picked up being the highest IQ percentile and being the 95th to 99th percentiles. And you can see that you get 2 and almost 4 percentage points as compared to our base, which is you're in the 4th decile, so just below the median. Finally, if we include education, you can see that actually these coefficients go insignificant. This paints too bleak of a picture. The other top income coefficients are still significant, so we're just losing power. Let me get back to you in a minute. You can see how parental education is further diminished. IQ is somewhat diminished. And just to pick one, this is the biggest impact. So if you have a science PhD, you get more than 20 percentage points. Okay? So that's an order of magnitude bigger than anything else. You had a question.
So when you see the plots that you were showing us, there are strong nonlinearities, and it seems that in the bottom of the distribution, the effects are much milder than in the top part. Have you thought about using quantile regressions to try to get these effects, this heterogeneity of effects across the distribution?
That's another good suggestion. We have to look into that. We haven't done it. Sure. Yeah, that's a good point. Okay, the last thing I wanted to show about this table is look at the R squares below here. Okay, so even when we throw in your own education, we explain 7% of the variation. So there's a lot to be explained outside our model. Okay.
You don't show the answer. I saw the expression of your paper, but you told me the answer.
Yes. Yeah.
One quick question about this.
Sure.
Do you have a similar table like where you condition on being an inventor and looking at the quality of the invention?
We don't condition on being an inventor, but we look at patent counts and we look at the probability of being a high-quality inventor, where we take, you're a high-quality inventor if you're in the top 5% of, your patent is in the top 5% of the citation distribution, and we get results that are very similar.
I was asking this along the line of what Nora showed yesterday, because it can also speak to the questions of efficiency. We can talk after.
Sure, yeah. To put this into context, we thought we need a comparison point. Murphy et al., and apologies for medical doctors maybe, but lawyers especially in the audience, they say that, well, look, inventors are very useful because they come up with new things and those are scalable, so all of us can benefit. Medical doctors are useful, but they can only operate 16 hours a day, so there's a limit to how scalable that is. And lawyers are mostly about rent-seeking. These are hard to enter professions, And so they give high income, so they're quite comparable to inventors in many ways. So we want to see how the same regressions would look like when we change the dependent variable from being an inventor to being a medical doctor or a lawyer. To set the scene, let me tell you that the probability of being an inventor in our data is slightly less than 1%. The probability of being a medical doctor is like 0.4%, and that for lawyers is roughly the same. So to make the coefficients I'm going to show you comparable, multiply the MD and lawyer coefficients by 2, or if you're very good with math, by 2.25, and then you have the comparison point. Yeah.
In the regressions you just ran, have you tried splitting it by, say, industry? So if you look at places that go...
Yeah, so the question was whether we've split the data by industry or taken into account where a person works, and the answer is we haven't. We already worry here that your own education is kind of a bad control if we're interested in parental background and IQ impacts, and that would be a further endogenous choice. Not that it's not interesting, but this is why we haven't done it so far.
But you can imagine actually just running that as a first stage, like a multinomial logit of industry choice as well.
Absolutely, I agree. Okay. Now, in the interest of time, let me show you the picture. So this you already saw. This is the probability of becoming an inventor. Here we have in red or maroon lawyers probability, and in green medical doctor probability. These are actually very close to, Xavier, what you have in the US for inventors in terms of levels. So we see that income matters for these two professions. Let's look at regressions. So I first show you the income coefficients. And so this is for inventors. For medical doctors, having a father in the top percentile gives you a 2.7 percentage point gain. You don't have to multiply that by 2 to have a much bigger number than here. The same for lawyers, it's 1.5%, which is more than double this. So clearly having a high income father matters more for becoming a medical doctor than becoming an inventor. Same for mother's income. We have 0.4%, 1.4%, and 0.5%. This right-hand column here is the inventor regression with education added, okay? Let's look at parental education. Having a PhD father gave you 1.8 percentage points gain. For becoming a medical doctor, you get 3.5 percentage points. For becoming a lawyer, you get 2 percentage points. And whereas PhD mother didn't really have an impact on inventors, it does have an impact on becoming a medical doctor. So parental education matters more for becoming a medical doctor or a lawyer than for becoming an inventor. Let's then look at IQ. So here you get either 2 or 4 percentage points for becoming an inventor. You get 0.4 and 0.5 percentage points. So even if you multiply these by 2, you get only half the impact you get for being an inventor. And for lawyers, there's no impact. Now, this is a little bit unfair for lawyers, okay? So if I showed the 90th percentile, there would be a positive impact. And I'm sure if we used verbal IQ, it would look different. But we use visual spatial IQ, okay? Yeah. But so, what is our take from this? Well, first of all parental background variables seem to matter more for these two professions than they matter for becoming an inventor. Well, how do you become a medical doctor in Finland? You go through high school, and then there's a competitive entry exam into medical school, and the same applies for law school. Those are highly competitive. Success rates for those who go to the exams is less than 10%, around about 10%. How do you become an inventor? Well, mostly also through education. You have to get yourself a science degree most of the time. That's also a competitive entry thing. But then you have to invent something. And one would expect that if there were credit constraints, they would be more binding in becoming an inventor than becoming a medical doctor or a lawyer, because tuition, there's none, and you get grants and subsidies, and you know you're going to be in a highly paid profession. Yet we find that parental income is clearly more important for medical doctors and lawyers than it is for inventors. This is why we think that the impacts we find from parental income on the probability of being an inventor are not just about credit constraints. They must be about something else, because a priori, becoming an inventor is a more credit-constrained activity than becoming a medical doctor or a lawyer. Yes?
Yes. So another question. Do you know the exact profession of the father? Because in some sense, if my father is a doctor, the payoff for me being a doctor is higher because he passes his reputation on me. Same thing for the lawyers.
That's not
like that.
Yeah, that's probably not true in the Finnish medical profession, where people work in the public sector in big health centers rather than having private clinics. So
even without public clinics is the case in Chile. Like my father, to give an example that I know, he works in the public health, and one of my cousins that became a doctor, everybody in the university was asking about my father, and then there is in some sense a reputation.
I'm sure there is. I could tell you similar stories from Finland. I have relatives who are in the medical profession, but I'm sure that also applies to sciences and to the law profession. So I'm not sure that they are an order of magnitude more important. But so we do know, we do...
Exactly, but what I was thinking is that might be showing up in the wage, because these are very highly paid professions. So if my father was a doctor and he earns good money, and I'm not controlling by the fact that he was a doctor, that might be showing off in the first coefficient.
You're absolutely right, and that's why we've already planned to run a robustness test where we separate. So having a father with a medical degree, he has a PhD, so that's, in some sense, it's already there, but we can separate out the medical doctor fathers to see whether there's an impact through that. We've had discussions on that. So there's a possibility there.
So I had a question in the sense that we are comparing the same things. So for medical doctors and lawyers, you just look at the occupation. But for inventors, I believe you are looking at only the people who have successfully obtained a patent.
Absolutely.
So do you think this is a nice comparison? And did you run a regression where you regress instead of being an inventor, just having a PhD degree, for instance?
That we haven't done, no. So that's something we could do, having a PhD in sciences.
And if you can observe the wages they receive as medical doctors and lawyers, perhaps you could run a similar regression where you just look at being a medical doctor that is more successful than a certain percentile, to have inventors who succeeded in a patent compared to doctors who are relatively successful.
Yeah, we can look into that, absolutely, thanks. So let me summarize. So we find that parental income matters even after we throw in parental education and IQ. For reasons I just explained, we don't think these coefficients reflect only credit constraints, although possibly also those. The impact of income is greatly diminished once we control for other characteristics. And actually, these other characteristics, parental education, own IQ, are more important than parental income in terms of the background determining whether you become an inventor. The IQ impact is convex and larger for inventors than MDs or lawyers. And own education is an order of magnitude more important than anything else. Okay, in the remaining 10 minutes, let me turn to returns. So the route to social mobility is through income effects. So you invent something, you get rewards. There's prior literature on that. And we're going to be looking at this in 4 ways. We're going to look at what happens on social mobility, what happens on income mobility, and what happens on your own log wage. And finally, also adding capital income. I'm going to be showing you the first 3, and the 4th gives us the same results as the 3rd. We're going to be looking at 2 groups of treated people, inventors and co-workers of inventors, and we're going to split co-workers by type. And the way we're going to be doing this is we're going to look at the impact on your wage on the year of the patent application and 10 years thereafter. And to set the scene, inventors earn on average 70,000 euros, non-inventors 25. Okay? So this is the specification. So here we have the patent count in year T and in the prior 10 years. And you being a co-worker, so you're a co-worker if somebody that you work with got a patent this year. We're going to add quality of invention, types of co-workers, so we're going to separate between senior and junior management, white collars, blue collars, and entrepreneurs. And we're going to look at whether you get a bigger payout if you're highly educated or if you have high IQ. And the base controls are the same as in the cross-section, region dummies, urban dummies, year dummies, plus now individual fixed effects on top of age. This is the OLS regression, and you can see that in the year of invention, you get almost 5% per patent. And then it fluctuates a little bit, but even 10 years after, you get 5% per patent. Let me throw in person fixed effects, and we see that clearly there's upward OLS bias. Now we're down to 2% in the first year, in the year of patent application, and then it goes down to less than 1%. But steadily there's a return up to 10 years. Let's look at co-workers. So this is a dummy for being a co-worker of any type, and you can see how they get almost 1% in the year of patent application and a return in the first 3 years thereafter. Then we actually get small negative returns, which might be hard to interpret. They might also, as you'll see, our base category is blue collar. This might be because of shifting production abroad. Let's then look at senior managers, and so the numbers I'm going to show you now is how much bigger is the return to senior managers than to blue-collar workers, whose numbers you see now in the third column. And you can see that the senior managers initially get essentially nothing more, but then they start earning a slight extra return on top of the blue-collar co-workers. If you look at senior white-collar who are not managers, we get pretty much the same story, although they start earning their small extra already somewhat earlier. And finally, the entrepreneurs, they get a big increase right after, and then substantially after the patent application. And you can see how from year 6 onwards up to year 10, there's like a 4 to 5% extra return on top of what all co-workers get. So what we find is that indeed inventors gain, co-workers mostly gain, and entrepreneurs gain the most. So there are wage spillovers from invention. To show you that there are quality effects, this is what you saw before for the inventors. Here's the same once we control for quality, and these coefficients are very close to each other row by row. And here's the effect of citation. So every citation to your patent gives you, in the year of application, 0.6 percentage points extra. So a big increase in the returns that were 1.7% to start with per patent. Okay.
Do you have in the data transaction of patent? Do you know if the patent was sold or kept?
Not that we know of. We might get that information, but
In case that you get it, if you go to the last regression, you see the big effect at the beginning for the owners, and then you see at the end, but there is nothing in between.
yes.
So it might be that you have two effect mixed. If you sell the patent of an application, you get the return at the beginning. If you keep it, you need to develop the project, and that takes, for example, 4 years, and after you have
Absolutely, very much possible.
So
Yeah.
these two things might be reflecting in some sense keeping an invention or selling it.
Yes. Okay, I see that I have 5 minutes and 10 seconds, so let me rush forward. So we look at the same thing from 2 different angles on top of what I just showed you. The first one is social mobility. And so here we have to define who's treated, and now a person is treated if he invents by age 33, and we're going to then look at his age at age 45. Okay? And we're going to have controls. We're going to do this two ways, first using all of our data and then doing what's called coarse and exact matching. So we find pairs of individuals that match by parental wage quantiles, parental education, decade of birth, IQ, age, and language. We take, whenever we can, a 3-year average round age 35 and 45, if that's available. If not, a 2-year average. And the first thing is what's called social mobility. How is your income related to your father's income? And so the dependent variable is your own wage percentile at age 35, and we compare those who have invented before that age to those who haven't. And here you see the results from the whole regression. So the first number tells you that the correlation between your percentile rank and your father's percentile rank, the partial correlation is 0.14. So increasing your father's rank by 10 percentage points increases your rank by 1.4 percentage points. Notice that if you're an inventor, the effect is the sum of these two, so essentially 0. So becoming an inventor wipes out the correlation between your income and your father's income, much more effective than being a high IQ person. High IQ here is being in the top decile. And there's a direct impact of being an inventor that shoots you up in the income distribution to start with. In the next column, I have the same regression, but using the coarse and exact matching sample, which you can see is way smaller, and the results are pretty much the same.
This was an issue that was raised last year when I presented your paper.
Yeah.
It's selection. How you recapturing inventing?
Yeah. So the last thing we look at is what's called income mobility. So how does the fact that I invent change my position in the income distribution? So now we take as a starting point where you are at age 35, and we look at where you end up at age 45, and compare those who invent in between to those who didn't. Okay, so the dependent variable now is own wage percentile at age 45. And the base variable is your percentile at age 35, and obviously there's a lot of persistence, okay, unsurprisingly. Notice how being an inventor between ages 35 and 45, not before, but between ages 35 and 45, reduces this coefficient by a quarter. Much more so than being high IQ. And again, being an inventor shoots you up in the income distribution. So both social mobility and income mobility are greatly facilitated by becoming an inventor. And again here, when we use the CEM sample, which is way smaller, we get essentially the same results.
I was just wondering about this result. So can you tell whether this being an inventor helps also to become an entrepreneur, and that's why you jump over this?
We haven't directly looked at that, but we know that in the raw data, the fraction of inventors who are entrepreneurs is lower than the fraction of entrepreneurs in the population. But this doesn't directly answer your question. So we should look into that. Yeah. Okay. Let me use my last minute to summarize. So we put together data from different sources to look at who becomes an inventor, the effects of inventing on your wage, on social and income mobility in Finland over 1988 to 2012. What we find is that, yes, parental income does matter, but actually less so than parental education, less so than own IQ. We find that IQ is important and has a convex impact. IQ is more important for inventors than medical doctors and lawyers, especially the visual spatial IQ we look at. And we find that father income is more important for lawyers and MDs than it is for inventors. That's why we think that the story behind these impacts from parental income is not only about credit constraints. And finally, own education is way more important than anything else. And once you put that in, all background variables, income included, parental income included, get further diminished. On the return side, yes, you get a return from being an inventor. It's a long-term return. It's not very high, but it's around 1 percentage point. Getting a higher per patent, getting a higher quality invention gives you a higher return. Being a co-worker gives benefits to most of them. It helps to be a white collar or an educated co-worker. It's especially great if you're the entrepreneur in the company. And inventing increases both social and income mobility. Thank you very much.